Beautiful. All right, so what we're gonna do today is actually we're gonna catch up where we left off last time, because we're still in the realm of GenServers. Like, we're still working with Elixir GenServers because we haven't really finished exactly what we needed to do. So we've got, for those of you that weren't here last time, let me just walk you through what we've done. So what we did is we created a GenServer that has basically all the logic in place to create a queue, like a queue for people to join in for every single streamer. That's great, but now we need something that supervisors all of these queues. And I think last time we also mentioned that at some point we need to maybe kill off these queues, because if every person starts a queue, at some point we need to also kill these queues, because if all the queues are empty, we're just gonna have empty queues like sitting here, taking up memory and processing power. I actually don't know if that's a bad thing. I don't know if that's like a anti-pattern, but I can imagine if you have like 100,000 streamers on a platform. I don't know how many like partners Twitch even has, but I'm assuming that they have quite a bit of streamers. If you're gonna have all these people start a queue once and then it never cleans up, that sounds to me like some kind of a bad and a waste of resources. We're not gonna look into that for now. Like, what we, I think, should focus on is creating some sort of supervisor to manage these queues, so that we can stick to the plan, which is to create an endpoint that we can create a queue for a streamer, and then people can join and leave. Just like the functionality we've built on a database level, we're going to be moving this to use GenServers instead and see if we can mimic the same behavior without locking ourselves into a database structure. Yuto! Yo, Mitrin, welcome to the Cats community. Thanks so much for the 45 centuries of continued support. Thank you so much, and welcome. So that's what we're gonna be looking at today. Just to figure out if we can create this manager. And I know that last stream we've already looked at agents, maybe, but also there was an example already where they created a registry of buckets. I can't remember what exactly this was. There's like buckets, and then there's a registry that manages these buckets, I suppose. Yeah, the registry, and then people can look up and create them. So I think that's actually what we're going to be doing, so that we can actually manage these and figure out like what we're gonna do. Also, welcome Lily. I'm not gonna watch this. Have fun. Bye. Gonna lurk though. I'm doing my homework. That's great. Good luck with your homework. Don't give me new knowledge. I won't. So they created a client API for this, the registry. I am not sure what to call this. We have a queue manager. Maybe that's the name that we're going for, but yeah. We've written tests that the queue itself actually has all the functionality that we need. So we can join a queue, we can leave a queue, we can pick people from a queue. We can find all the players, we can get the position of a single player, and we can clear, like wipe the queue, which is awesome. So I think the next thing we're going to be looking at is the manager. And I think what we have here is the GenServer branch. So maybe we should actually merge this. I don't actually know if I want to merge this. Like, I don't know if this is the functionality I want to go for. Maybe just make a branch off of this branch for now. Add queue manager. Wait. How's live though, Mitrian? Manager. And we're gonna just continue off basically the same thing that we do here, which is also a GenServer. And for those that don't remember what a GenServer really is, it is something that can hold a bit of state or can do certain actions based on events. So you call, you basically do a GenServer call on a specific instance of the gen server, and then you pass it the command that you want to, you know, of the action that you want to perform, and then the server handles these actions. So you can see like handle call. If somebody calls it with join, then do this. And so it's like a nice black box that you can just call shit into, and then that like the gen server itself will react to whatever you're doing. So it can hold a certain state, it can make a change to it. It's a nice way of like holding state in some shape or form and make changes to it in different ways. So the purpose of this manager is that it's gonna be mapping a streamer name to a queue. And on top of that, we might want to have... Like, I think this is difficult. Because we'll be supervising a bunch of processes, but I'm not sure that's supposed to be happening inside the gen server. But let's just take a look at the example, because the registry is exactly what we are doing. Like, look up. This is like the testing. I thought this was the example, exactly what I'm looking for. No, this is not it. Maybe it's the example in here somewhere. This is a stack. Maybe I think this is the thing. Introduction guide. I know that there was exactly something that we were looking for. Sup, Huka? Sup, Lavra? Hey, you sexy beast. What is poppin'? How is life? How is life? Registry. Yes. What is this called again? Is this a tuple? I always forget what, like, the syntax. Tuple. Is this a tuple? That's a tuple. So it's not a tuple. It's a list. No, it's a map. It's a map. It's a map. This is a map. It's really hot today, guys. So, okay, here we go. This is it. This is it. So we create a registry, and then we create shopping, and then we look up shopping. Okay. And then process monitor. Oh, here, start link, bucket. This is what I mean. So we create, and then it checks if there is already one available for this name. If so, then do no reply. Otherwise, create a new bucket, monitor the bucket, which I don't know what that is, and then you put the reference to the bucket. Let's take a look at what process the monitor is. I don't know what that is. Yo, Alvin, thank you so much for follow. Welcome, welcome. How has your day been? Process. Convenience for working with processes and the process dictionary. Okay. Besides the functions available in this module, the kernel module exposes auto imports some basic functionality. Okay. Chugging some Elixir today. That's it. That's it. Are you, or are you telling me that I am chugging some Elixir today? Maybe it's a matter of both. Life is good. How is your life? Life is excellent. Life is excellent. I've been sitting in my living room the entire day and I didn't realize that it was so hot in this room. 25 degrees in this room. It's not good. That is not so good. Okay, what is this? This Tells whether process is alive. Delete the given key in the process dictionary. So I suppose Elixir also keeps a dictionary of... Okay. Oh, there is already a registry. A local decentralized and scalable key value process storage. This is what we need. This is what we need. Why would I do something if it already has it for me? Depends on what your Elixir is. My Elixir is code. I don't know what your Elixir is. I'm chugging down the knowledge of Elixir. Oh god, what is this? I think this is another... Let's just go low level first and then learn the abstractions. Let's go over there first. Okay, so we have a bit bigger chat with bad eyes can also see it maybe on mobile. This is what we would have as a queue. And then this thing is a registry. So in this case, for us, this is the manager. The manager manages streamer queues. We create a ref using process.monitor. So monitor starts monitoring the given item for the calling process. Once the monitor process dies, a message is delivered to the monitoring process in the shape of down ref process object reason, where ref is the monitor reference. Object is either a PID of the monitor process or name node if monitoring a remote or local name, and then the reason it exits. So it's probably exit code. So we spawn a process here. We spawn like... Oh, I didn't know you could do that. Interesting. So you spawn something, you get a PID, and then you exit the PID, and then you have a receive block. So this is all kinds of new syntax for me. Everything we've done so far have been implemented with an agent. Okay, let's just read through the entire docs again. In the previous chapter, we used agents to represent our buckets. Yes, sure, fine, fair enough, cool. And we can put and get stuff inside of these buckets. This is like a basket, right? It's like you're going shopping, and this is my basket. This is what I put in. So I put in my shopping basket. I put in milk 1. And I can get 1 out of the shopping basket. It's cool. Or I get the amount of milk in this case. However, naming dynamic processes with atoms is a terrible idea. So here I say start an agent with this, and then on that agent we give it a shopping name. But if the clients pick the name, then you don't want atoms like to be used here, because like atoms have a finite amount of a number of that can be living inside the VM, so that's a bad idea. I did Elixir all day today, just going to cough down some coffee now. Okay, that's all good. That's all good. Take a chill pill and enjoy your coffee. This is already... Well, this is what I remember from last time, too. I need to not skip over things, because I'll be missing. This is what we already learned. Generating atoms from user input would mean that the user can inject different names to exhaust our system memory. Cool. In practice, it's more likely you will reach the Erlang VM limit. Sure, instead of abusing built-in name facility, we can create our own process registry that associates a bucket name to a bucket process. Excellent. The registry needs to guarantee that it's always up to date. For example, if one of the bucket processes crashes due to a bug, the registry must notice this change and avoid serving still entries. The registry needs to guarantee that it's always up to date. One of the bucket processes crashes, the registry must notice the change and avoid serving still entries. Sure, yes. That's in Elixir, we say a registry needs to monitor each bucket. Okay, our manager, let's just our manager needs to monitor the queues for every streamer. Cool. Because our registry needs to be able to receive and handle ad hoc messages from the system, the agent API is not enough. We will use a GenServer to create a registry process that can monitor the bucket processes. GenServer provides industrial strength functionality for building servers in both Elixir and OTP. We can read the document. Cool. Yes. Awesome. That's what we already knew. But like, what is important here, I think, is that they're using the term monitor here. Because that seems to be like emphasized here. Like they're literally saying a registry needs to italic monitor, which is like, it seems to be something important. Like it's important lingo if we're using it. Yeah, okay, cool. That's what we're gonna do. Sweet. Registry, init. Okay, I think we can do the same, pretty much. So we start off that our initial state is an empty map because we will need to map the name of the streamer with a queue. Because we don't want people to create infinite amount of queues. Like if you have a queue, you have a queue. That's just it. I'm just waiting until you get to the part of supervisor and say why we even do this when supervisor does everything. Because I think it will show us a lot. But I think I will get to a point, yes, where I also still don't know what implement true is. Is it like a GenServer requires some stuff to be implemented and you need to mark it as implemented? I actually don't know. I also can't remember what the difference between call and cast is. One was async and the other one was synchronous. This one seems to be asynchronous because it's creating this. So I suppose this is like asynchronous. What kind of underlying methods do we want? We want to, I guess lookup and create can work actually. We can just change this to streamer. And then, names. I don't like the idea of calling this names. Because if I remember correctly, it's like reply and then the piece you want to reply with and then the new state. I think, if I remember correctly. And so like this is not really streamers. This is like this is like the map, really. But I don't know. Streamer queue mapping. But maybe that's too verbose. I don't know what. I don't know what the convention is here. Because I also find it weird here that they are lookup name in the names. But in reality, it's not really in the names. You're searching for it like in the map of names to bucket, really. Name to bucket. And here it's like streamer to queue. So you're like fetching out of the streamer to queue map. You're fetching the streamer. But I don't know. Naming is hard. But let's just stick to what they have. It's fine. So we're looking for streamer. We're creating with the name streamer, and then we check, does the streamer already exist? And then if so, then we do no reply because we already have it, but we don't update the state, but we need to respond with the state that we didn't make any changes to it. So we just return with the exact state that we have. Perhaps later on, if we want to create a new queue, I don't know if the intention is that we should wipe the queue that they currently have, but that is something to figure out. And then we want to do queue, stream link, and then queue by default is that, so we don't need a value here. Yep. And then state. Maybe state is the best. Maybe state is the best thing. Maybe that's the least confusing thing. Because I think that's generic enough that it almost can be used anywhere, really. Because what you're only concerned about is the changes that you make when a call is made. Like as a developer, what you really want to do is you're probably gonna do something with the state that you've stored in this thing. And for us, that is in the manager, that is like the mapping between a streamer and a queue. Yeah, so this is not bucket, this is queue. So we store in the state, we store it by streamer, the value queue. Cool, makes sense. That's awesome. There's two types of requests you can send to a gen server: calls and casts. Calls are synchronous, and the server must send a response back to such request. While the server computes the response, the client is waiting. Casts are asynchronous. The server won't send a response back, and therefore the client won't wait for one. Both requests are messages sent to the server and will be created in sequence. In the above implementation, we pattern match on the create messages. Yep. To be handled as cast, and on the lookup messages, we make a call. True. In order to invoke the callbacks above, what this makes me wonder is that if we create and then do a call, is there always a guarantee that it has handled this call? Because if this is asynchronous, I don't know if this can take a little bit of time. Is what I'm wondering. Anyhows, in order to invoke the yep, and now we're gonna look at the client API, yep, and then we're just gonna do that too. Sure, yep, cool, sweet, awesome, sweet. I don't care about docs. People would already know what this is, or at least I know what this is. I don't know if that's like normal. We can do it like this one. Just say like you. We have no real options here. Perhaps we want to start it with a certain state, maybe. Initial state. What did we say here? Default? Sure. Sure. When is map? Hope that's a thing. And then we say by default, it's this. But then probably in it should have this value. And so we say, what did we say here? The stack. Wait, we call, okay, we called it a stack. In this case, we call it the map. I don't know if that's... Sure. Sweet. Cool. Awesome. Start link. And then we do here, server callbacks, sure. Wait. Cool. Look up the server and then we create. Okay, so what we do here is we don't call it lookup. So what we do is we call this get queue. Or find queue. I don't know what the thing is. And I'm fine with lookup here because that's like underlying. Maybe it's get like this. This is fine though. What's up, Jonas? How's life? And then we do it here, streamer. That's probably better. And then when we create streamer, it is a queue manager. Is it weird that I just say get? Probably, right? Get queue. Yeah, it's probably clear. Cool. Okay, now we have a good client interface. 30 degrees in my room right now. It's 25 here. It's getting even warmer tomorrow, I've heard. I have a fan, though. I could have just grabbed the fan. I also don't know if the convention is that these things match up. Like get, for example, that it's like kind of like match these. But I think underlying the call can be made like look up for the streamer. So that's fine. Okay, so what now? Okay, let's make a test because that's what they're doing. Let's do that too. Manager test. I also don't really know what the extension EXS is, but I guess we might figure that out at some point. Manager test. I also don't know if manager's the right thing, but that's fine. Probably need both. Okay, what do we want to test, really? We want to test these public ones. We probably want to delete. Yeah. Kill. You kill a queue. You delete a queue. Clean the queue. Because we're not interacting with one queue. We're trying to, like, just completely wipe it, you know? Just completely wipe it out of your map. Destroy? Maybe it's like create queue. Get queue, create queue, destroy queue for a streamer. Destroy. And then we need to implement destroy. Do we expect this to be synchronous? Do we expect this to be synchronous? I mean, in theory, I also expect create to be synchronous, but that's not the case. So let's just follow the pattern here and just go with this. If it's not found, if it is found, we want to delete it. Stop. Oh, here it here it shows what they're doing. Let's first play with monitors. So you start a bucket, and then you process the bucket. What? Oh, wait a minute. Hold up. Now we're getting to something interesting because we already saw this before. Like last stream, we already saw this, but I actually didn't know what this was for. Interesting. So this is notifications from other processes, like kind of events that you've subscribed to, kind of. Maybe not really, but This I don't really understand yet, though. Because we put refs... Okay, so we're not actually storing... Hold the phone. Okay, wait a minute. Okay, let's just follow the tutorial. You know, like, let's just not get ahead of ourselves. Let's not do destroy yet. I think we'll get there. Let's just start with this simple interface and write tests. That's what we're gonna start with. Sup, horse? Sup, you doing? Sorry. Sup, Makeler? How's it going? You're your fan on full bore and it's nice. It's one of those evaporating ones. Ooh. Oh, damn. Alright, let's think about the test cases. So what we want to test is that we can create create and get queues. I don't know what we did in here. Did we did should test join? Okay, sweet, nice and concise, awesome. Creates can create and get queues. That sounds more like it. That sounds more like a test. Okay, what we're gonna do is we're going to be creating a manager dot start link. And then what we get back is okay PID, I suppose. And then we pattern match that, and then what we do is we create something for a streamer. So let's assign this to a variable called streamer, and let's add ourselves to it. And then what we're gonna do is we expect... Oh, we can assert this even. Hey, what? Oh, what is this? Hold the phone. Okay, all right. So when you try, okay, test cannot get queue when not created. I'm not sure if that's clear at all. Okay, so this creates a registry. In this case, for us, it's a manager. So maybe we should just get queues like they did. And then manager. Because then we also gonna queues queue. Maybe that's not super nice. Maybe just manager is nice. How many decisions? Start supervised. So this is... Okay. The manager. So in our test, we can now have access to the manager, which is nice because now we always have a manager available. Unless we want to test. Yeah. Can we create a manager with the same name? Yes, we can. Yeah, we have that covered. Yep. Okay, so if we do manager dot get queue, and then we pass in the manager, and then we say to just draw cats. Not sure if I'm supposed to, I think I might do like lowercase. I'll just put it to lowercase. Okay, let's try this test. It should fail. Should be fine. Okay, I didn't expect to feel that hard. Cannot find or invoke local defaults. Wait. Oh, I think this is the wrong way. Syntax. I think this might be like this. Yeah, okay. Wait. I haven't seen you since you played your Minecraft Let's Play. God damn. Long time. Failed to start child with spec, blah blah blah. No function clause matching manager start link. Start link. Is it always supposed to be an array? Oh, sorry, a list. Here, I always see list. Because I think this is a default state, no? State. Yeah. Why can I not do what I just did then? Start link. Yep. Confused. Slightly confused. Initial argument. See? Yep. That's what I'm doing. Defaults. Oh, it's not map? Is that really what this is? What is this then? I don't know my fundamentals. Chat. Help. Elixir. Elixir. I thought this was a map. And is it something else? Docs. Elixir standard library. Yes, I think I was just there, but... This is not a tuple, right? Cool. What is it? Record? Okay, that's not it. Records are simply tuples when the first element is an atom. Okay, cool. Module? No. Okay. List, keyword, map. Go to key value. This is what a map is. What? Okay, let's remove this and see what happens. Oh, now you're working. Expected a map, got okay. What? Where? Manager 32. Got okay. Huh? Okay, stack. Okay, map. What? Oh, boy. Found it. Wait. When? Still don't know why this doesn't work though. Now it's gonna fail again. Still don't know why. Manager 11. Oh. Start supervised. What does that do? Start supervised. My server initial value. Huh. Okay. Okay. Manager. Wait, I don't have an initial value. Why is it automatically by default? What? I don't understand that. We say start supervise manager, but then why is the default value not this boy right here? Let's see what the default value is here. Why? 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 Nobody told you it was going to be an empty list. Nobody. So I think Start Supervise is doing that, but that's weird. I didn't ask for that. You piece of shit. Start link. My server. Other supervisor. Just find some examples of this. Oh, start supervised. Okay. We can find more examples. It's fine. Google has my answer. Shit, this is complicated. This is quite the Jesus. This is quite the gen server. This is when you're really good at Elixir. I don't understand. Oh, we're getting to the tests of the source code. Look, that is obviously sick. Start link with an error. Yeah, so, okay, you know what? Fuck the world. I don't actually understand, but let's just roll with it. Let's just roll with it, you know? Maybe his map just doesn't really, you know, do its thing. Let's try that again. Because I would assume that the default is, you know. Yeah, I don't know. I don't know why start supervise. It doesn't say anywhere that it by default calls start link with empty list. Seems a bit strange because I just assumed that you would pass nothing in it and then it would default to this value. But hey, who am I to judge, right? Who am I to judge? Who am I to assume? Cool. Okay. So we got our first test, which basically says if you are getting a manager, or if you're asking the manager for the queue of Jizzro cats, but you know it doesn't have it, then you're kind of screwed up. And then we have a manager, so we don't need to create one every time. And then what we do is we say manager.create manager, and then we say the streamer, and then we assert that we get back okay with the PID, What do we actually expect? Wait, what do we expect? Yeah, because this is asynchronous, right? So like what we should do is we can call it, and then we can assert after that we can call manager get queues, and the queue is created. And so we assert that we get a queue back, and we do manager dot get queue manager streamer. And then we can assume that we can do things with the queue now. So I assume that we can assert that we can get the players queue dot players with the queue. And that it asserts to empty list, and then we can assert that we can join it. But that's maybe a bit out of the, you know, Bob Ross. And then maybe that's a bit much. Maybe all we want to know is that this returns us back a type of queue, an instance of queue. That makes sense. Can we do that? Elixir test type module. Because what we get back, what do we actually get back? What do we actually get back here? IO inspect. I think we get back the actual PID ID, like the PID. I think so. We don't get a queue. Oh yeah. Is that weird, actually, now that I think about it? Why do I get OK back? Is there a way that this can fail? Why would this ever fail? If I want to get the players, I would just get the players, no? Can't remember why I did this. I remember that we changed it. I just can't remember why. But that's okay. Yeah, we got the PID back. Cool. Okay. Sweet. Awesome. Remove this. So we got our first two tests working. You can tell it to fail if you want. Yeah, but like why? Why though? Why is it actually fail? Why would it fail? If I do a call to players. See, this is just a reply. Okay. I just remember, I think what we did is we wanted to maybe streamline, because for some of these we would actually put an error back. So maybe we just said like, okay, let's just for all of them just put okay or nothing, you know, like so streamline the API. It's fine though. It's fine. It's all good. If instead of okay state you put in state, you will get the state back. Yes, but that's what I mean. Like, there is a reason that I did this, and it's probably, I just can't remember because it's the last stream. But I think there was a reason. And also don't look at the code too much because it's rarely complicated, but it's fully unit tested, so at least we can change it later. And if you're good at Elixir, Alvin, maybe you can suggest me some ways to refactor. But let's first just get into the manager part and just get our, you know, our hands dirty into getting this working. Because as long as we have it unit tested and the API doesn't really change. Yeah, exactly. You just did Elixir all day, so. It removes the buckets on exit. So we kill a bucket and then it errors. That's our next test, which fails. Cool, let's do that. That's what I want. We assert that when what do you mean? This is a weird test name, actually. Removes buckets on exit. That's not true. It removes the bucket if it fails. Anyways, it can remove multiple buckets if multiple exit. Yeah. Removes the queue when it crashes. Removes the streamer queue. Cool. So this is the manager. I don't know if manager is a good name, but for now we'll just roll with it. And then we say manager.create, and then we call it just raw cats. And then we say, you know, this is what we already have, so let's do the same. Streamer, and we get the queue. All good. We don't assert anything because, you know, we already tested it in the previous one. Yeah, we have a queue. This is actually all prep, so in theory we can just do this. And then we stop it. Kill the queue as if it crashed. Actually, it doesn't really matter whether it like crashes. So the agent stop, it's not an agent, so I don't know if this would work. Maybe it's process.stop, because like we're working with a second gen server here, so maybe, you know, process.exit, maybe that's, you know, if I kill it. That's actually good. Let's just check it, you know? Let's just check it. So if I process.exit the queue with the kill command, will I still receive a message? Probably. And then we try to look up again. Kill the queue. I think this is fairly speaks for itself now, which is nice. And this test should not fail. Yep, because it's still in the registry, because we're not listening to any messages from children. And so if we monitor it, okay, let's read this part, because this is the very interesting piece. Everything we've done so far could have been implemented with an agent. In this section, we will see one of the many things that we can achieve with a gen server that is not possible with an agent. Let's start with a test that describes how we want the registry to behave if a bucket stops or crashes. The test above will fail on the last assertion because it remains in the registry even when the bucket process stopped. In order to fix this bug, we need the registry to monitor every bucket it spawns. Once we set up a monitor, the registry will receive a notification every time a bucket process exits, allowing us to clean the registry up. That is so fucking cool. I really like that. Let's play with the monitor in the terminal. Yeah, let's do that. Let's do that. Let's do that. Let's do that. What the fuck is it doing? Okay, and then we get a queue, and then we or a manager. Or, yeah, queue. A queue. Okay. What was my thing? Viewer games. Viewer games dot queues dot queue dot start link. It has a default, so this should work. Nice. Okay, we have a queue now. And then we do process of monitor. What I don't understand is how you can just flush. It's like we have a reference to something. I don't know what flush is. Flush? While in the shell, you might find the helper flush like 0 arguments useful. It flushes and prints all the messages in the mailbox. What the fuck? What do you mean mailbox? Sure, man. Yeah. Is that is that Erlang Mailbox? Process messaging. I think I've read about this. Processes in Erlang share no memory, hence they're communicating via message passing. Each process has a mailbox. The receive block allows a process to do something with the messages in the mailbox. A process can receive different kinds of messages, then act on them. Interesting. To send... This is actually a really nice format of explaining Erlang. This is really nice. I like this. This is cool. This is really cool. A process can receive different kinds of messages, then act on them. To send a message, the process uses the exclamation mark operator. Preceded by the process ID you want to send the message to. Make request is a function that takes a server ID and a message, and then server ID exclamation mark message. So the server ID, and then we're sending the message. And so what we're doing is we spawn a module, or we spawn a process, and then we say, we take the PID and we make a request to this PID with this request one, which I don't know where it's defined. Nowhere to be defined. Fantastic. And then we sleep, and then we spawn PID 2. I don't understand. Anyways, let's continue reading. Just getting ahead of myself here. How does a process handle received messages? When a process receives a message, the message is appended to the mailbox. The receive block will try each message in the mailbox one by one against the block's sequence of patterns until one of the messages matches a pattern. Boyd, words, it's very hard to read. When there is a match, the message gets removed from the mailbox and the logic corresponding to the matched pattern will be executed. That makes sense. Yeah, that's like what this is. This. If there's no match, then that message remains in the mailbox, and the following message gets tried sequentially against all of the received block patterns. Okay. So that means that if you don't have a match for the message that you're sending, it will just linger in the mailbox forever. So if you ever make a typo in production, you make a typo in the message, like pattern matching message, and you shoot it in production, then for that process, you might have processes that have lingering mail in the mailbox, like lingering message in the mailbox. That seems interesting. If no message in the mailbox match any pattern, the process have tried all messages and have executed all received patterns will get suspended until a new message arrives. Oh. No messages in the mailbox match any. The process, having tried all messages and having executed all received patterns, will get suspended until a new message arrives. And the message processing logic starts all over. Beginning with the first message in the mailbox. Okay. Interesting. Cool. That's good to know. Okay, so flush, which I guess the process of IEX has then the mailbox, and then flush will show that. Like, let's go back to flush. Flush. It flushes and prints all messages in the mailbox. Sent to self. Yeah, so like the IEX process, those messages. Right, so like if in the IEX like process, we are process of monitoring, then this current process is going to be monitoring this PID, which means that my process will receive messages, but because I don't have a receive block, the only way to see the messages in the mailbox and clean them out, you can use flush. Okay, makes sense. Cool. Awesome. So I can do process of monitor PID. In this case, it's Q. And I get a reference, and then I can do agent stop, which is for me process dot kill, right? That was what we did in the test. Exit. Q kill. Shell process exited with a reason kill. What? Okay, maybe... What? But we're passing into Q. We want to kill the Q. Why did my... what? There's nothing in the mailbox. That's interesting. So maybe process.stop, process.exit is a bit too... Process.exit. Oh, this is like way too generic to Google. Process.exit. Sends a signal with the given reason to PID. Yeah, that's what we did. Why would it kill the above one? And what if it isn't an agent? Can I still do agent stop? Let's try it. Let's do the same that we did before. We create a queue, we monitor the queue, and then we do agent.stop queue. Okay. Flush. Oh, would you look at that? So maybe we shouldn't do process.exit because apparently that doesn't really, sound like a good idea. So let's do agent.stop. Don't know what the difference is though. Let's look at the source code maybe. Function keeps OTP semantics regarding error reporting. If the reason is any other than normal or shutdown, an error report will be logged. Okay. It expects an agent, which can be a PID. Actually, I think we can also do GenServer.stop, no? Yeah. Okay, yeah, we didn't actually monitor it. Okay, that makes more sense to me, considering that we're working with a GenServer. But I kind of interested in GenServer, Elixir, GitHub. Kind of curious why, you know, like what is it using under the hood? Stop. Dev stop. Exit. That's what I did. What do you mean? If the PID is self, then stop yourself. Okay, bro. What if it's not? Proclib stop. Exit with calling self. Exit Erlang. Oh, it calls exit because there is dev exit, right? No? Where does the exit function come from? But it's only D6. Synchronously stops the server for a given reason. Terminate 2 has been invoked before exiting. The server returns OK if the server terminates with the given reason. If it terminates with another reason, the call exits. The function keeps OTP semantics regarding error reporting. Yeah, okay, so that's what we already read. Cool. Cool. Okay, so we can just do stop. All goods. Cool. Still don't really understand why process.exit with the kill actually killed the parent process. Don't really know about that. Maybe it's the error reporting that was kicking in. Because maybe if I do something else, we can try that. Let's create another one. And then we do process.monitor queue. And then we do process.exit queue with normal. Or just maybe just process.exit. Okay, it does need 2 arguments. Process.exit Elixir. Exit. Reason. Normal. If the reason is the atom normal, PID will not exit unless PID is the calling process in which... What? Sorry, what now? Sends an exit signal to the PID. The following behavior applies if the reason is any term except normal or kill. If the PID is not trapping exits, PID will exit with the given reason. If PID is trapping exits, the exit signal is transformed into a message exit from reason and delivered to the message queue of PID. If reason is the atom normal, PID will not exit unless PID is the calling process, in which case it will exit with the reason normal. I have no idea what the fuck that means, but whatever. If it is trapping exits, the exit signal is transformed into a message, blah blah blah. If the reason is kill, that is, if process exit PID kill is called, an untrappable exit signal is sent to PID, which will unconditionally exit with the reason killed. Sure. Okay, so that did not kill it. But there was also no message. Process is alive. That was something too, right? Hibernate. Alive question mark. Could be true? What do you mean? I thought we killed it with normal. So what if I kill it with some other reason? Okay, what if we do GenServer stop queue? So at least we know it's dead. And then we do flush and it says, yep, it died. And then we just respawn it again. Normal doesn't kill. Yeah, apparently. That's weird, because you're calling process to exit on it, and then you're like, actually, don't exit. Okay, so we have a queue, and then we do process.monitor queue. And then we do process.exit. And then we do queue, and then we do YOLO. And it killed the entire process. Exit from this. Shell process exited with reason YOLO. I'm really confused. I am actually really confused why the parent process dies. That's interesting. Also, this scares me a little bit, I'm not gonna lie. Hibernate. Puts the calling process in hibernation state. The calling process is put into a waiting state where the memory is where its memory allocation has been reduced as much as possible, which is useful if the process does not expect it to receive any messages in the near future. Oh, interesting. Is there stop? No. I don't understand. No connect. When used, if sending message would require an auto connection to the other nodes. If sending the message would require an auto connection to another node, the message is not sent. Huh. Cool. We're learning. We're learning a lot. Still a little bit confused, not gonna lie. But, you know, it is what it is. It is what it is. Sometimes, you know. Okay, we can actually see process.alive question mark q equals true. That one should not be true. That one should be false. Yes. So the GenServer stopped the queue and the process is dead. That shouldn't happen. Yeah, that's what I'm thinking. That does not sound like something that should happen. Let's try it out in the, you know what? Let's just try it out in the test runner. See if it dies there too. That doesn't die. It did kill. So process dot alive question mark q equals true. What's your OTP version? Really, like quite one of the latest versions. Erlang -v. Erl -v. Oh, that's okay. That doesn't work. OTP 22. BRTS 10.6.4. Could also just done that, but yeah, strange. Maybe it's a bug from older versions. Really? Am I old already? Is Erlang 22nd? Is that old? OTP 22? Are we? Where are we? Shit, we're on 24. What do you mean? Oh god. Oh. Here I am thinking that I was, you know, up to date. Things move so fast. Anyhows, this is a tiny oopsie whoopsie. It's all right. It's all right. Maybe I'm not wrong. Maybe it's just cool. So we can do process exit, or we can just do GenServer.stop. Maybe GenServer.stop sounds a bit more safe to use the abstraction that is like linked to the actual code. So let's use that. All good to go. Process exit though, on the other hand, is very low level. That's okay. Your logic isn't wrong. Erlang is just bugged. Okay, sounds good. Let's continue. Note that process monitor PID returns a unique reference that allows us to match upcoming messages to that monitoring reference. After we stop the agent, we can use flush all messages and a notice down message arrived with the exact reference returned by monitor, notifying that the bucket process exited with reason normal. Okay. When I do process and exit normal, it does not down it. Interesting. Let's re-implement the server callbacks to fix the bug and make the test pass. First, we will modify the GenServer state to two dictionaries, one containing name to PID and another that holds ref name. Okay. Sure. Yeah, let's then not be able to start this with a state. Do I really need to start it with a state? No, right? And then can I do that? Let's hope for the best that that exists. Start link with only one argument, and then we say there's two things here. There is the streamers, still weird to me, and then there's the refs, which I don't really know yet what that is, which is I think for monitoring, right? So we create a monitoring ref and then we add it to the refs. So this is like monitoring references, and then we have the streamer to queue map. Maybe this is just queues per streamer, queues by streamer. But it's not really a queue, it's a process ID. But, you know, queue references by streamer. Queue by streamer. Queues by streamer. That's fine. This is fine. Excellent. And then we return a... What is this? What is this called? A list? This is not a list. This is not a tuple. This is a... No, this is a... What the fuck is this? I can't wrap my head around this whole syntax. I always forget what things are called. It is a tuple. Yeah, okay, it is a tuple. What was the other one called? When it starts with a thing. Record? Record is simply tuples where the first element is an element. Okay, cool. This is a record then. But then this is a tuple. Today I learned. So order is important here. What did they do? Did they do refs first? Doesn't really matter, but for my own sake. Names first, refs second. Cool. I don't know if that's the, you know, I like to be a bit verbose. But maybe the more I create, this is probably going to get abstracted away by a supervisor anyways, but it's fine. You know, like we're doing this by hand for now. So let's update our code first and have those tests pass. So what we're going to get is we're going to get two pieces here of the state. We're going to have the queues by streamer and the monitoring references. Do we use that here? Because I don't think we do. So then we can say yeet. And then we say queues by streamer, and then we say state this. And then we say streamer state here, and then we do the same thing. Queues by streamer, blah, blah, blah. And then we say monitoring references. We only use that to initialize. Yes. And then also for handling info. So if the queues by streamer has the key streamer, then we return the state. Because then we don't do anything. And otherwise we create a queue. And then we add it to the monitoring references map.set. Monitoring this put. Okay, sure. Makes sense. Monitoring references, and then we also need to monitor it. So we do, what do we get? Reference. Monitor. Process.monitor. Monitor reference. Sure, let's just do it verbose, you know? So here it is. Key is the reference. Value is the name of the streamer. Okay, sure. Does it matter? Do we want to find them by monitor reference? Oh, yes. Because then we find the streamer name by the process that died, and then we remove it from the... Yeah, okay. Yeah, I think I understand now. So we save the streamer. Let's monitor the process so we can clean up the queue if the process dies. And the rest is just this. Add this to queues by streamer. Oh yeah, we need to combine the state. Does it matter which one I do first? I guess this can fail somehow. And the streamer. Map the streamer name to the corresponding queue. Yep, that makes sense. And then we return new state. Yikes. And new monitoring state. Ugh. Not a fan of that naming. Use. Monitors. Monitoring. Refs. Can I overwrite this? Can I do this? Probably bad practice. Not a fan. But this should at least fix the existing tests. Okay, we broke something. That's good. Failed to start this. Yeah, that makes sense. Oh, here we go again. Now we're gonna start this fucking supervisor with the wrong input again. Are we? Start link with 1. Okay, yeah. Cool. But this one with 1 does not exist. Can I do nil? Okay, that definitely broke. Terminating. Process monitor undefined or private. Oh. Sense. Sub-zero. Ooh, that does not look good. Oh, yeah, okay, this makes sense. This makes sense. This is all because of that test. Map is undefined. Map's not used. Yeah. Oh, we can do that. I like that, actually. Yeah, so this makes sense because we're killing the process, and then our manager, because it's monitoring, has a reference to this process monitor. So all of a sudden, this manager process now is listening to messages, and it's calling a method on this for something it doesn't have like anything for. So like if I do def handle info any do and IO inspect any, I would see it as IO inspect. Just kidding, I don't. Handle call lookup. What? Okay, so handle call 3. Lookup just requests PID. This is the from PID. And then the reference. Oh, so PID and then the reference. And then this is what is being sent. Oh yeah, our return type is wrong. Yeah, so monitoring references. We need to also return that. Yeah, our state changed because of a buggy. Tiny fucko boingo. Okay, we're good. Handle info still doesn't work, but that's okay. I think there's more arguments to it. What's up, Honey Stack? How's it going? How's life? How's this beautiful Wednesday? Way too hot. Cool. So I think we're only with the last test now. The last test that's failing. I think we're starting to understand it. Just doing a tiny fucky wookie. I am getting more sick and tired of these names. That's okay, because I think we will at some point understand that we will be using supervisor here. So now we're going to be actually doing this work. So there is handle info, the specific case. So this is what I was referring to. If I implement this and I do IO inspect message and IO inspect state, now the error will be gone. Yeah, and we will see the inspecting, but this assertion will still be wrong. But we can see that there is something coming in, and this is useful because this is what we need to pattern match on. So let's do that. So let's do imp true, which I still have no idea what that does, but let's do handle info. And then let's just get an example in here. And then when it's down, we get the, what is this? This is the monitoring reference. And then we get the PID. And then we get the reason, which we don't really use. Or do we? Do we pattern match on that? Oh, this is different. Hold up. Oh, there's two. Forgot about that. There's this one, and then there's this one. This is the first argument. Huh? Message state. Ah, yeah. Cool. Yeah. What do we want to do here? We want to delete it, right? So we need to get the monitoring references and the queues by streamer. So we'll need to update it. The linter will fix this for me, so I don't need to care. Ah, okay. We map pop a specific reference which we got from this monitoring reference. And then we say monitoring references. And then we say name is what we get. And then the rest. Streamer. Damn, these are like very ugly lines, but for me, having it verbose for a little bit is just making things a little bit easier. And then we have a map, and then we have the queues by streamer, and then we delete it for a specific streamer, and then we get new queues by streamer. And then we just no reply with the new tuple, which is the new state. And then for the rest, we just like listen to it and just see the messages come in. But like, you can also not do that. And just do this. And then in this case, we would have the test passing. And then the variable PID is not used. PID reason, yep. We're good to go. Pog. Massive Pog champ. So now we have a queue manager. So we can start a queue manager, and then streamers can create queues which other people can then join. Nice. Sweet. This is what we needed. And then observe that we were able to considerably change the server implementation without changing any of the client API. That is one benefit of explicitly segregating the server and the client. Finally, different from the other callbacks, we have defined a catch-all clause for handle info that discards any unknown message. To understand why, let's move on to the next section. So far, we have used 3 callbacks: handle call, handle cast, and handle info. Here's what we should consider when deciding when to use each. Handle call must be used for synchronous requests. This should be the default choice, as waiting for the server reply is a useful back pressure mechanism. Handle cast must be used for asynchronous requests when you don't care about a reply. A cast does not even guarantee that the server has received a message, and for this reason, you should be used sparingly. For example, create function we have defined in chapter should have used call. We've used cast for didactic purposes. Oh. Well, today I learned. The nice thing is, though, is that under the hood, we can just change the implementation. And it doesn't really matter. So let's commit this first before we change it. Because the tests are passing. And let's use the linter too. Mix lint. Mix format. Cool. Beautiful. Yeah, let's go. Cool. Add initial implementation of a queue manager. Wait. Oh wow, this is... Sure. Works for me. Okay, let's now change it to be call. And then make this a call. And then add from here. And then that's it, really. Oh, it should probably reply. Reply with okay. And then the new state, right? New state equals... I don't know why I did that. Or do we expect when you create, it should probably give you the queue. Like the PID of the queue and not the new state, but we set the new state. Why would you make it call? So call is synchronous. So like our system does not really talk to anything that we really need to wait for. This is all need this, like we all need to basically, if I create a queue and I immediately call lookup, there is a chance that this queue is not created yet because it's asynchronous. But in theory, like we're doing synchronous like things here. This stuff shouldn't take long, and if it does take long, there is probably a bigger problem. Like we're not making external calls here. We're not calling the database, or like we're like even for the database, you could argue that like you might want to wait. But yeah, we're not like, yeah. We expect like when you create a queue for a streamer that the person wants to get the queue back. And they said here like the create function that we have defined should have used call rather than the other one, cast. Cast is more like you shoot it into the wild and then, yeah, you just assume that it's being handled. Which is good for probably stuff like listening to an event and then doing some stuff for it, like hooking it up to monitoring or like sending a log or like writing it to a log file where it's like fire and forget sort of thing. You just like do something, but you don't really care about like knowing what the status of it was. So like I am creating a queue, and then when a queue is created, I'm shooting an event, like I'm sending an event to process the care, or I'm posting something to like an event log like process, and then that process just like logs it to a disk or something. But like you just fire and forget. You shoot it into the wild. You tell like the event listener like, hey, you handle this. But maybe for an event listener, you still want to maybe use synchronous because you want to get an acknowledgement, the fact that it happened. Yeah, I don't know. Still really tough for me to really get an understanding of when to use casting. Yeah. And then we have handle info. So let's see if our tasks pass. Yep, but we can even make the test better now because we can now assert when we create that we also get an OK with a queue back. And that the queue is the same as the get queue, actually. How would I assert that? Get queue. And then we assert that queue equals queue. So like we assume that we're getting the same queue back. We're not expecting a new one. And then when this one is create here, we can say okay with the queue, and then we can remove this get call because we don't really care. And now we've optimized our tests a little bit. And streamer is unused, but we could still use it. Streamer. What's up, Wolfie? How was your stream? Yeah, if you guys haven't checked Wolfie out, please go check him out. How was Phasmo? Awesome. Beautiful. Let's do some formatting. Boity died to Dragon Rage. Oh, you were doing Pokemon. I thought you were doing Phasmo. I don't know why I thought you were doing Phasmo. Oh. You did both. I see, I see. Yeah, I think this is fine. Factor manager to use call instead of cast. Cool. So now we still need a way to actually destroy. What is the right term? Why is it still called create, actually? I thought this was called create queue. Okay. Maybe destroy queue. Okay. So we want to see. If there is a queue already, then we want to remove it. Otherwise, we want to just reply with... Is delete something you want to fire and forget? Not really. What are you building, my friend? Subsimilar? I am basically changing how I was using the database before, and I'm moving something into memory. But what I'm building is basically a way for streamers to manage viewer games. Like an easier way. And then we build a whole platform on top too, you know, to make it awesome. Ooh, actually here this should also be like error. Or should this be okay? Maybe this should be, we're trying to find the streamer, and then if... What do I expect? I think I might just error and say like... Streamer already has a queue. Queue already exists. Something. And I kind of want to flip this around, you know, like... Oh, we need to do reply with error. Queue already exists. And then here we do reply with queue not found. And we can do the same here. We do map fetch. Or we return error. Is that what is expected? I'm actually not sure. Handle call, like error management, like how is that normally handled? Handle call. How are you doing, this Somalar? Are you also a developer? Not really what I'm looking for. Let's just keep it as is. Just roll with that for now. Let's just roll with the same sort of error. So when you're trying to delete or destroy a streamer's queue, we want to like stop the process. So first we want to get the queue. So we get the streamer from the queues by streamer. So what we get back is a queue. And then we can do case, do, end. What do we get back from this call? Map get. Oh, there's no get. Okay. Otherwise nil. Okay. That's fine. So we can do this. If nil, then we do reply with error. Otherwise, we get the queue. And then we say we do GenServer dot stop queue. Don't forget to return state even in the error. True. True. Is it better to reference state here? Can I do this? Can I do like both states? Yeah, you can? Wait. Because I was like, otherwise I need to create a new sort of like tuple instance. Either direction is fine? Okay, okay. Cool. Okay, so state. We need the state anyways. And we need to pop it out of both. This is tough actually, because in this ref, we don't know the monitoring reference, but that doesn't really matter. Oh. What does map delete do when it doesn't exist? This does not exist. Returns the map unchanged. Okay, cool. So it already handles that perfectly. Can I test that? Probably. Let's write a test for that. Can we? Actually, that's not possible. Right? Well, it is possible now. If I destroy it twice, will it crash? That's like a good question. Okay, so when the queue is there, we want to stop the queue, but I think we want to do that at the end. Or not. No, we want to stop it first. And then when we stop it, we get a message. So that's pretty much actually the only thing we need to do, because it will clean up itself based on the message here. Clean. Clean. But then we still need to return a reply saying that it was okay. Is that a valid return? It's like just like this? That's kind of weird, right? Because the top one is like, you just do this and then state. Oh, but we have a new state not yet. That's kind of weird, right? Because we're stopping the queue, but then asynchronously we have handle info, and then we pop it here. So like if I do GenServer stop, it will not wait for this message back to be sent out, and then we reply with the old state. It's kind of weirds me out a little bit, because in one way it's clean, but if we then consecutively in the same runtime make a call like to look it up, it might still be in the state of the manager. So I'm curious whether that's like a bad thing to do, because if you want to make this fully synchronous, maybe we can stop monitoring. I think we can do that. I think that's what we should do. We can force it to wait for a reply, like the GenServer stop call. Is that the right way to do it, or should I actually just reverse everything? Yeah. So like I should, in theory, rather like stop monitoring it, remove it from the monitoring refs. Are we removing it from monitoring? Yes. Why are we using pop here and then delete here? Oh, because it gives us a new state. No, but we do that here too. Oh, we pop one off and then we get the value. Okay. And here we don't care about the value. We just care about the new state. Cool. Awesome. So Sweet. I think actually that might actually simplify this code because I think this is doing exactly that. We're doing some recursive, like, yeah. Anyways. Not sure if that was for delete or whether we were using delete properly. Leave. List delete. Okay. What does map pop do when there's no references to it? Keys present in the map returns blah blah blah. If the key is not present in the map, default, and then map is returned. And then here we pass in default is map. Default values. It's probably nil. We're passing nil to delete, and then don't know what happens. We'll see. We'll just figure it out. Yep, it's fine. So let's do the opposite of create, which would be like stopping the gen server, removing the monitoring first, and removing it from the state first, then stopping it. But what if stopping does not work? Can that happen? Gen server stop Elixir. Like, what if it hangs? There's a timeout. Sounds pretty scary. Like, I'm not sure how it's supposed to behave. Because that sounds weird, right? Like, we're stopping it, and then while we're cleaning up the process, I don't know how that works. Because, like, I don't know if I should handle this like as asynchronous, right? Like, if I do gen server stop, like, and I go in the next line here and I do like this, I suppose the state that I'm working on is actually, yeah, it didn't update. There's no, yeah. Okay, this is fine. It's fine that I stop it first. It's fine. They all get their own slice of the state that they have in that moment of time. So I don't have to care about like that multi-threading problem, and we're all touching the same instance. It doesn't really matter, because if they get a slice of the state, it will be fine because they will do their piece. And if that's not fine, then I'll do my piece. You know, like either way, when either one replies first, we'll have it sorted out. So what we need to get, and this is kind of shit, we need the other way index too. We need the monitoring reference by streamer, because in this case we only know about the streamer, not the monitoring reference. And the question is, can I get the current monitorings or a given process ID, which would be kind of a little bit problematic, because if there's other people monitoring my process, that is kind of a problem. So that is interesting. What if I flip it around? But then this one won't work, because here I only have the process, not the streamer. So it's almost like I need to store it two ways. Ugh. How's your stream going? Doing fine. I'm learning a lot, actually. It's really fun. Maybe I'm over-optimizing it, though. What's map set? Data structure that contains... It can contain unique elements of any kind. Let's just do the ugly way first. We can always optimize it after. So what I need is I need to loop through the values and then find. And I do map find. That's what I need to do. So I need to go through the references and then find one that matches the value. So this is a map, key value, and then we find it's not okay, we also have like a map is also a enum, right? So like we also inherit the enum ones. And so what we can also do is enum map maps the given function over numerals and flattens the result. Group by what is into? Enum 1, 2 into this new thing. Inserts a given enumerable into a collectible. Okay. I guess you could do map key value and then value key. Is enum actually? I do reduce. I'm gonna do it the ugly way, it's fine. So what we have is is there an example of a key value one? I love just overcomplicating it, but what is zip? Oh, these is like key and values, and then you zip them into one another. Like if you're zipping your shirt, it's like left and right match. Zip reduce. Stream zips, enums, accumulator reducer. Holy moly, this is powerful. List to tuple. It loops over the enums, starting with this list, then the elements, then this list to tuple, and you map them into... Okay. To list. Find value. Find. This is what I need. Find. Okay, let's try that. Is it mix? No. Dash S. That's it. Oh. IX dash S mix. I always forget. Okay, we have a list of Bob to Ross and Foo to Bar, and this is like our refs. And then what we need is we need to do enum.find fn. I don't know how to do key value though, but I think you could also do that with map, so let's just find that. Key value, cool. Key value into oh boy. Yeah, I just need to find... I need to find one, right? I need to find one where the value equals to Ross. End. Bob Ross. Okay, and then we take the first one out, which is the key. Wait, that was easy. So we find the reference ref and the streamer. Ref. No. Key. Streamer. No. So the key value into value equals streamer. End. So now we have the monitoring reference. Maybe. Because what if it cannot find it? It returns default. And the default is nil. Okay. Okay, that's fine. And then we just do this. Map.delete the monitoring references by monitoring reference. And we don't really care what the result. We do care. Because we need to update this. So. You think types don't have a place in Elixir, or wouldn't types improve Elixir's readability? I mean, I would actually really like it. Because of how much more powerful the compiler gets. But what's up, Endo Functor 0? How's it going? I don't have enough like experience with Elixir though to be able to say like, oh yeah, that would be fantastic. I always like types though, because it just compilers can be like super helpful. My code is I'm not feeling very like good about my code right now, but as long as it's bombarded with unit tests, this is what I always say. If you get more familiar, we can always do a stream where we just refactor shit, which I think is also important. Stop the actual queue GenServer. Remove the monitoring reference from our map. And then, or we're find the monitoring reference for this queue and streamer. Remove both the monitoring reference and the streamer queue from our state. And then we return with the new state. Is there anything that could go wrong here? We cannot find it. This will be nil, and then map delete nil. So let's test that real quick. There is always Gleam. Gleam. I thought there was actually a video. Type safe scalable system. What is this? This is like a compiler for Erlang, or is this a new language? Built on top of Erlang. So it's like next to Elixir. I used to develop in Ruby, and there's now like something called, oh, what is it called? Like built by Stripe, I think. Sorbet? Yeah. And I think I remember a talk at one of the Elixir cons, like last year or something, where the creator of Elixir, I can't remember his name. I just like it starts with a J, but I can't remember. Like Jonas or something like that. I think he tried actually finding a way to add types to Elixir, but he couldn't find a syntax that would like that he would enjoy, and the problems that come with it, or like some static analysis or something like that. Okay, I think we have what we need. We can now destroy a streamer queue. So test ability to destroy a streamer queue. We have a queue for a streamer, and then we assert that the queue is there. We can do that by doing this. I always like doing that because you can make this two assertions, like one before and then one after. So like you have a reference point, like maybe before it was already deleted, and now you can make sure like, okay, I assert that before it was there, and we can guarantee that. But afterwards we make the same call and now it's gone. So then what we do is we do manager dot destroy the queue. Don't really care about that. And then what we would get back is okay with something I don't care about. Or we could say destroyed queue, and we can assert that the type is the same, just so that we have like the validated that the interface that we're exposing is correct. Even though like in most use cases you will not even make use of that, because if you're deleting the queue, you would already have the queue PID, and afterwards this PID is useless. So it's kind of a weird thing to have, but and then afterwards this call should error out. Is there any internal stuff that we want to test somehow? Because like I can also just stop the process and then still have a lingering state, but I can do that by making the get call, and we can assert that the thing is actually destroyed. So we can do process.alive (this equals true), and then we can also assert that the queue, if the manager gets the queue for this streamer, it would result in error. And then what we can also test should not able to destroy a non-existing streamer, or destroy an already deleted destroyed streamer queue, just so that we have that test covered too. So we create one again, and in this case this test is already covering that. So what we want to do is we just create a queue, we destroy it, we assert that it is destroyed, care about the destroyed queue here, and then we assert that if we call it again, it would actually error, and it would say something that we talked about here. Queue, no. Oh, we didn't have that specified. Queue not found. Is that weird? If the queue is already destroyed and you're trying to destroy the queue again, should it say queue not found, or should it just say okay? Because if it is already deleted, that's always the question that I have. If you delete a record that already does not exist, should you say okay, or should you say couldn't destroy because it doesn't exist? It's always this weird concept. I just never know like which case to go for. What's normal? Oh, it should be false. And here it should also be false. Let's test. Broken. What's wrong? Variable key is used. Sure. Compilation error. Undefined function manager. Ah. True. Okay. Test the ability to destroy a streamer queue. Destroy one. Alright, we need the streamer. Okay, destroy 2 is undefined or private. Destroy queue. Okay, here we go. No handle call for destroy just cats. Let's see. Handle destroy just cats. Call. Yes, correct. What's up, Dirk? How's it going? How's it going? Interesting. Troy Q streamer. Troy Q streamer. So it says there's no match for handle call 3, but we have it here. Maybe these two don't match with this. Kind of confused. Okay, it's fine. We can just do it like this for now. Okay. Just to be sure that I'm correct here, because it's calling GenServer call PID destroy JuzzRockCats 5000. And then it calls it destroy JuzzRockCats PID reference empty list. Empty list? What? Prepare to be annihilated. Yeah. I'm not sure if that's the nice thing to call it, but let's just see. This is handle call. I don't think we're getting there though. But that might be just because... Oh. Wait, it's failing on... What? Why is it... Wait, why is it inside the queue? Destroy. What's the queue doing? There's no destroy on this. That bro. So somehow... What? This was fine, this was fine. All the other tests are passing. We're calling manager destroy queue for streamer. And then we expect a destroyed queue to come back. But what we actually are doing is we're somehow calling queue.handleCall. How the fuck are we doing that? What language is this? This is Elixir. Elixir. Handle info. Empty map. Handle call. Why is this an empty list? Where is this ever returning an empty list? I don't get it. It's like, hey yo, I am calling destroy on a queue too, which is super weird. It's like, what do you mean? Where am I actually triggering a call to server? Oh, I see. Oops, I already know. In my test, I'm passing here queue while it should be manager. Yeah. Okay, now it makes sense. I'm like, wait, what the fuck? Okay, we're good. I was passing the wrong PID. So it was trying to call destroy on the queue. Oopsie. Ah, there we go. Now everything's passing. Tiny oopsie whoopsie. Tiny oopsie whoopsie. Never worked with that? I don't have a lot of experience with it either. But it's a functional language. Okay, there's still IO somewhere. Alright, here. It's very interesting. It's like, it's a language that is built on Erlang, which is a very old language. Which has been created by Ericsson, like the mobile provider, build like the mobile system, the mobile network, not the mobile, even telephone network stuff. And they have like something called OTP, which is like, what is OTP actually? Is that the actual VM? Well, anyways, they have something like a VM, like it's called the Beam VM. And it's like the Erlang's like virtual machine. And it's like, it just mimics a lot of the concepts that you have of like a normal PC, like a normal operating system that is running inside like this Beam VM. And so your code can basically work as if you were working with like processes and stuff like that. Which is very interesting because a lot of our work is like bound to crash somehow. And so like they've built this language with the philosophy that if you're working with telecommunication, things have to be up all the time. So you're doing basically a lot of the heavy lifting inside of tiny processes. So in this case, I'm writing a viewer game app. And so I have a queue, which is just, if you look at it from the client interface, it's like you can join a queue, you can leave a queue, you can have players inside the queue and view them. You can have a position of a specific player in the queue. You can pick any amount of players from the queue. It's like plucking them out. And then there's clearing whatever is in that queue. And this queue is like a tiny process, like a tiny like server that you run. And so with this instance of this server, you can interact with its own state. So in this case, the state is just a list. And you can join it, you can leave it, you can do whatever. And then now we've written a manager that you can like, which is also a GenServer, which is just a process that manages like queues. So like now I can create like a manager that manages, I can create queues and I can get the queue for a streamer. And then this queue for a streamer is just an instance of, you know, this queue right here. there any integrations with Docker? Yes. Yes. So this is not an actual VM, you know, like it's not a actual virtual machine. It's just something that looks a lot like a virtual machine. Like it has the concepts of a virtual machine. So it doesn't actually like triple down to processes in Linux, for example. Like does that sound like it works similar to Docker? You could, I guess you could say that. Sure. Because in theory, you have like a Docker process, and then, you know, it shares some of the stuff with the host OS. But in this case, it doesn't. I guess it does, in a way, because, you know, it doesn't implement everything like a normal VM would. Functional standpoint. I guess. Like, I don't know enough of it to be able to say, like, yeah, they're so much similar. But like, nothing stops you from running like this Beam VM inside of a Docker container, deployed that way. But the interesting thing is that it's very fault tolerant, because like if my queue crashes, my app doesn't crash. It just like stops, and it might just create a new queue. So like I can literally decide if one of my queues crashes for a streamer because I have a bug in my code, just create a new one. Spawn a new instance of this queue. And you can even tell it like how it should do that. Should it persist some of the state? Like, should it build up some new state? Like, what should it do? So for example, I think in the app that we have, let me see. Let me see where I have supervisor. Here. So you can see that, like, by default, this is the root application. So my viewer game application. And it has two processes that it starts at the beginning that need to be supervised. And there's even a strategy of what it should do when one of them crashes. And so one of them is the repository, which is like your database connection. And then, which is the active repository. And then the other one is just your web, like, app. There's a mosquito in my room and I need to kill it. So hard to see with all this stuff. But yeah, that's basically the concept of it. I'm not 100% sure yet because I'm still learning. But for now, we have a fully working queue and manager system. So I can create queues for certain streamers. So now we're closer to what our goal is, which is to just have an endpoint, which we can create a queue for a streamer, and then other people can join the queue. That's the goal. And then, yeah, that's like what we're gonna do. And then we also need some sort of like expiration of a GenServer, because if we create a queue for a streamer, create a queue for a streamer, we don't want it to be lingering if it's not used. Yeah, so create, find queue. That actually kind of mimics what we have in the manager now. It's like get queue, find queue, create queue, destroy queue. And then we need something like a worker that just goes and asks all the managers. So we need a supervisor of the manager that will go through and ask the manager for like, hey, give me your queues. So let's do that, because that's also what we need. Get queues. Server. So otherwise we cannot do that supervising, but let's do that after. Let's first just be able to do the actual work. So what did we do here? So we've renamed create queue. And then what else did we do? Let's format. Oh, we missed one. What? Oh yeah, we also need to handle that. Actually, we need to test this. So when you're creating a streamer that already exists, we're now erroring out. Oops. Let's add a test for that too. Test cannot create queue for streamer that already has a queue. So we create a queue for a streamer, just cats, and then that's okay. And then the second call that we make, we get error back, and then we expect that it does queue already exists. Sweet. 46 tests. Oh. Manager does not exist. Oh yeah, true. I keep doing that for some reason. Like how the test still passed. Oh no, it didn't. Compilation error. Oops. Something broke. Queue already exists. Bad return value. Oh. Huh. Wait, what's wrong here? Reply. That's good though, right? Oh yeah, we're missing state again. Distinct state. Go, go, go. Hey, that's why we write tests. Let's go. Yeah, let's do two different ones. This is just renaming. Yeah, rename method. Sure. This is like add validation, add error for yeah, unit tests are big PP energy, exactly. Add error for when a streamer has already owns a queue. Cool, and then the rest is all mix format. Forgot the formats. Cool. And then the rest is all for destroying a queue. Add ability to destroy a queue for a streamer. It's not the prettiest code because I'm very verbose so that I can fully understand what is what. But it's okay. So there's pattern matching, something called pattern matching. So you can see that I have two methods called handle info. One is like very specific. So I only want to handle the case of down when you're calling handle info with a tuple that starts with down and then some value that we call monitor reference, and then like an atom called process, and then something like PID and a reason. And we get state, and we destructure the state. It is a tuple from both queue and monitoring references. If that doesn't match, it will automatically fall back to this one, and it will just call this one. And so you can see that handle call has all kinds of different formats here, which allows us to only handle stuff that we expect to be sent to us. Like, let's say you have a module called dev module call later. What did I do wrong? Oh. And I do like do. I'm not sure if that's a reserved word. Like run. And then I can have run that does add, and it has like number 1, number 2. But I can also have run add like subtract number 1, number 2. And I can have whatever I want. And the examples that they have are more like a little bit better, because this seems kind of useless. You could just have 2 methods, you know, like these are not supposed to do, you know, do the same thing. But anyways, in this case, if you call GenServer call on a server, in this case ourselves, we call it with lookup, which is what we're doing here, and then the streamer, which is what we're doing here. So we're matching the payload. If the payload is sent like this, then this like clause is called. So we don't have a switch statement, because normally you would have something like, if you call this, then like payload, and then you would do like a switch statement with like payload, and then you would have like for every single case starts with, or like the first argument in payload matches like something, payload 0 matches with like lookup, and then lookup you call like the lookup method and stuff like that. You can do something similar with this, and you have like very specific. So I think for temperature they had an example where they like call a method like get temps or something, like and then you tell it like what to use or what to convert it to. So like it could use Fahrenheit or Celsius, and you specify what your input is, and then it calculates it to, it switches it to the other one. Like an interesting example. So like you could still use the same method, and it's dependent on like what their input is. You just swap it. Cool. Sweet. So we're handling a bunch of different calls, like destroy call, create, and lookup, which is nice. Let's continue with what we were reading. Yeah, so monitoring down messages is an example. So there's more regular messages that you can send. Since any message, including the ones sent via send to, go to handle info, there is a chance unexpected messages will arrive. Therefore, if we don't define the catch-all clause, those messages could cause our registry to crash. Yeah, so handle info will receive messages because we were monitoring like some stuff, but other processes can send messages to other processes. So it could be that we will receive messages that we don't want to handle. And so if you don't define this, it will try to call this, and then it sees that it doesn't match, and then it will just blow up because there's no other method defined. So like if this doesn't exist, we're only handling this specific case, but there's no other method to like fall back to. So then it just crashes. and then it will crash that process. It will then probably be restarted depending on like what our rules are, but in this case, yeah, it depends. We don't have to worry about such cases for handle call and handle cast, because calls and casts are only done via the GenServer API, so an unknown message is quite likely a developer mistake, so we want it to crash. Yeah. To help developers remember the difference between call and cast and info, the supported return values are more... have a GenServer cheat sheet. Oh. Hello? Oh. Wait. Yeah, so this we already knew. This is what we found out the hard way, just like by doing it. Cool. Okay, we have previously learned about links in the process chapter. Now with the registry complete, you may be wondering when we should use monitors and when should we use links. Links are bidirectional. But links. Oh, wait, this is something else. Links. The majority of times we spawn processes in Elixir, we spawn them as linked processes. Before we show an example with spawn link, let's see what happens when a process with spawn fails. So in our like command line, we just do spawn and then we throw an exception and then it says process raised with an exception. It merely logged an error, but the parent process is still running. That's because the processes are isolated. If we want the failure in one process to propagate to another one, we should link them. You can do this by doing spawn link. Self is this PID. Spawn link, raise an exception, and then when one fails, the other one fails. Because the processes are linked, we can now see a message saying that the parent process, which is the shell process, has received an exit signal from another process, causing the shell to terminate. IEX detects this situation and starts a new shell session. It's funny because, yeah, so that's like probably the bug that I had. Linking can be done manually by calling process.link, but we recommend that you take a look at the process module for other functionalities. Cool. Oh, we even have to task. That's cool. Task, start link, loop, receive. Cool. Yeah. Okay. So link is when you don't want your process to die. Monitor is when you probably want to get updated when it dies because you want to keep your state in updated. Cool. If you link two processes and one of them crashes, the other one will crash too. A monitor is unidirectional. Only the monitoring process will receive notifications about the monitored one. In other words, use links when we want linked crashes, and monitors when you want to be informed of crashes. Yeah, that's what I thought. Okay, cool. Returning our handle cast implementation, you can see that the registry is both linking and monitoring buckets. This is a bad idea, as we don't want to the registry to crash when a bucket crashes. Oops. The proper fix is actually not linked, is to not link the bucket to a registry. Instead, we link each bucket to a special type of process called supervisors. Which are explicitly designed to handle failures and crashes. We'll learn about that in the next chapter. God damn it, we built something that we're gonna throw away, but we already knew that. In the previous chapter about GenServer, we implemented the KV registry to manage buckets. At some point, we started monitoring buckets, so we were able to take action whenever a bucket crashed. Although the change is relatively small, it introduced a question which is frequently asked by Elixir developers, what happens when something fails. Before we added monitoring, if a bucket crashed, the registry would forever point to a bucket that no longer exists. If a user tried to read or write to the crashed bucket, it would fail. Any attempt to at creating a new bucket with the same name would return the PID of the crashed bucket. In other words, that registry entry for the bucket would forever be in a bad state. Once we added monitoring, the registry automatically removes the entry for the crashed bucket. Yes, that's what we did. So we said, when you create a queue, we process the queue and then we store a reference to that monitor in our state so that we receive messages like down when one of our monitored references died. And so then we can kill it. We can remove it. Sweet. In practice, we're not expected the processes working as buckets to fail, but if it does happen for whatever reason, we can rest assured that our system will continue to work as intended. If you have prior developed programming experience, you may be wondering, could we just guarantee the buckets does not crash in the first place? As we will see, Elixir developers tend to refer to those practices as defensive programming. That's because a live production system has dozens of different reasons why something can go wrong. The disk can fail, memory can be corrupted, bugs, the network may stop working for a second, etc. If we were to write software that attempts to protect or circumvent all of those errors, we will be spending more time handling failures than writing our own software. Therefore, an Elixir developer prefers to let it crash or fail fast. And one of those common ways we can recover from failure is by restarting whatever part of the system crashed. Interesting. For example, imagine if your computer, router, printer, or whatever device is not working properly. How often do you fix it by restarting it? Once we restart the device, we reset the device back to its initial state, which is well tested and guaranteed to work. In Elixir, we apply the same approach to software. Whenever a process crashes, we start a new process to perform the same job as the crashed process. In Elixir, this is done by a supervisor. Supervisor is a process that supervises other processes and restarts them whenever they crash. To do so, the supervisor manages the whole lifecycle of any supervised process, including startup and shutdown. In this chapter, we will learn how we put those concepts into practice by supervising the KV registry process. After all, if something goes wrong with the registry, the whole registry is lost and no bucket could ever be found. To address this, we will define a supervisor module that guarantees that our KV registry is up and running at any given moment. At the end of the chapter, we will talk about applications. As we will see, Mix has been packaging all of our code into applications, and we will learn how to customize the application to guarantee that our supervisor and registry are up and running whenever a system starts. Okay. It's funny because this is exactly what we need to do. So we have something that manages our queues, but we don't have something that manages our managers. Because our manager can also crash. All right. So now we create something called a supervisor. And we dev module and then viewer games.queues.supervisor. Cool. And we use supervisor, which is given by the core library, and we do start link options supervisor start the current module that we're in, which is this one. Okay, which is for the init, and then init, and then we say you supervise the manager. So let's alias that. Viewer games.queues.manager. And then you initialize the supervisor with a 1-for-1 strategy. Our supervisor has a single child so far. After we define a list of children, we call supervisor init, passing the children and the supervision strategy. The supervision strategy dictates what happens when one of the children crashes. 1-for-1 means that if a child dies, it will be the only one restarted. Only one restarted. Children? Yeah, child processes. It's like a weird term that we like came up with the programming world. It's like it's so weird. There's like so many memes about it too. Child process meme. Like killing a child, and it's like FBI, and it's like killing a child process, Stack Overflow, and then the FBI is chilling. It's like it's classical programming. But I mean, like we also have like in the DB terms, we also have some very bad terminology. Like we've changed it now, but it was like master slave. For example, these are like terms that we were using, and I think the programming world is slowly moving away from these like weird terms to like something called like primary, secondary, or like master replica, or like primary replica, stuff like that. Because yeah, master slave, we don't really want to be thinking about that, you know? Master slave configurations. I think people are trying to move away from these terms to just like have primary replica. Or at least I know that like that is being like enforced in some companies. Let's see. So we have a list of child processes, and we have only one process like registry that we're doing. The supervising strategy happens when one of the children crashes. 1-for-1 means if a child dies, it will be the only one restarted. So since we have only one child, that's all we need. The supervisor behavior supports many different strategies. We can discuss them in this chapter. And we will discuss them in this chapter. Once the supervisor starts, it traverses the list of children and it invokes the child spec function on each module. The child spec function returns the child specification, which describes how to start the process if the process is a worker or a supervisor. If the process is temporary, transient, or permanent, and so on. Interesting. So if we do, we can call that. Cool. Like, let's do ix as mix again. So we open up and then we do viewer games dot queues dot manager child spec empty array. Oh. What if I don't pass anything? Okay. So the ID is this, and then the start, these are the start params. Child spec function is automatically defined when we use agent, use GenServer, or use supervisor. Give it a try in the terminal. Yeah, programming world is gonna get canceled. We will learn those details as we move forward with the guide. If you would rather peek ahead, check the supervisor docs. No, I don't care. After the supervisor retrieves all child specifications, it proceeds to start its children one by one in the order they were defined, using the information in the start key in the child specification. For our current specification, it will call KV registry start link with the array. That's actually, oh yeah. These are lists of arguments, so that's why it's duplicated lists here. This is so weird to listen to, I'm sorry. Let's take the supervisor for a spin. Okay, so it starts the supervisor and then it, oh, it does which children. Interesting. Viewer games.queues.supervisor.start link empty list. Oh, oops. Okay, now we're gonna spawn another one. Okay, now we have two. It's fine. Supervisor. Can't spell that. Dot which children or PID is of type worker. So we started, so far we started the supervisor and listed its children. Once the supervisor started, it also started all its children. What happens if we intentionally crash the registry started by the supervisor? Let's do it by sending it a bad input on call. Sure. Okay, so he takes, sure, he pattern matches, because this is a list. So he says we pattern match, and then we take the first one, which is this one, which is this tuple, and the first one is like, we don't care about that, so we underscore it, and then we get the what is this? The queue, no, the manager PID, and then we do exclamation mark or like underscore underscore. Yep. So we pattern match on the first tuple, and then we tell it that we don't care about this one. We only care about this. We don't care about this, and we don't care about this. So now we have something called the manager PID, and now we can do viewer games.queues.queue. No, we have the manager here, manager, and then we just do handle. No. Oh, we do GenServer. GenServer call PID. Oops. Manager PID, and then a message that we don't actually know about. So like YOLO. Boom. Process crashed. Because it says like, hey, you tried to call YOLO, but there's no function that is handling this call. Boom, explodes. And then we do supervisor, which children, and then PID. And then it says, you can see that the manager is now, wait, it doesn't have a different PID? Yeah, it does. It was 449 and now it's 455. Notice how the supervisor automatically started a new registry with a new PID in place of the first one, because we crashed due to bad input. In the previous chapters, we've always started processes directly. For example, we would call KV registry start link, which would return OK PID, and that would allow us to interact with the registry via its PID. Now that the processes are started by the supervisor, we have to directly ask the supervisor who its children are, and fetch the PID from the return list of children. In practice, doing so every time would be very expensive. To address this, we often give names to processes, allowing them to be uniquely identified in a single machine from anywhere in our code. Let's learn how to do that. While our application will have many buckets, it will only have a single registry. Therefore, whenever we start a registry, we want to give it a unique name so we can reach out to it from anywhere. We do so by the name option. By passing a name option to registry start link 1. Okay, let's slightly change our children definition to be a list of tuples instead of atoms. Okay. And then we do name equals Viewer games, or we can just do manager. Interesting. So because these module names are also atoms, or these modules are atoms too, you can basically link it and say, if you, this is the actual, like, this is the actual, like, server, like GenServer, or the module that you can call dot, what was it? Link, like link children or something, link child? Was it called? Child spec on. And then because this is also a atom, we can name it and then reference every, like, if we ever want this, like, supervised manager, we can just we can ask the supervisor to give us the manager. That's interesting. And then because when we pass this is what gets passed to the start link of this one. Suppose. Yeah, start link options. So we give it, oh, this is the queue. Need the manager. Options. And then we pass it the options here. Which in turn will register the process for the given name. Cool. But that's just because we give it name and this. We could have also just done this, but that might be a bit confusing. And then say like name and then do it like this, name. That could have also worked. But that's a bit confusing, like, because it looks a bit ugly. So I think this is like the standard that everybody uses. Like, extra arguments are done here, and then your start link will have options. Or maybe it has like initial state and then options depending on like what you need. The name options is expected an atom for local named processes. Local named means it's available to the system. There are other options which we won't discuss here. Cool. Since module identifiers are atoms. Oh, this is exactly what I said. If I do viewer games.queues.manager. Wow. Interesting. Chaos mod for Terraria. I came a bit out of the blue. That would be kind of cool, actually. What did we talk about before? Or Chaos mod for, what was it? Chaos mod for, I don't remember what it was. For Minecraft? I mean, you're a Java dev, right? So you can make Chaos mod for Minecraft. Since the module identifiers are atoms, we can name a process after the module that implements it, provided that there's only one process with that name. This helps when debugging and introspecting the system. Supervisor start link, registry. Oh, cool. That's sick. That's really cool. So I can do viewer games dot queues supervisor dot start link empty list. I don't know if that's the default. I guess because of the, oh no, that's the manager. Because of this, yeah. So this is like a pattern you see. Like start link, you pass options. So I can actually give this one a name too, the supervisor. So now it should have started the manager, and then if I do just viewer games dot queues dot manager dot create, and then I do viewer games dot queues dot manager. Wait, let's alias that because I'm just getting sick and tired. Viewer games dot queues dot manager dot create queue queues dot manager. Because this is bound, this atom is used, it will know it because it's globally registered now. That's so cool. That's so nice. I see now. Now this all makes sense. Oh. Let me see. What about like those player thingies? Repo get player. Maybe that's something else. Viewer games repo. You can see it's using the same thing. See? Oh, but we'd call. Okay, so we name the supervisor actually. So because actually that's interesting. Why does this exist? Or does it not exist? It's just wait, if I do viewer games dot YOLO and it doesn't exist, is it still an atom? It is. So even when it doesn't exist, like even if it's when it's not defined, it's still an atom. Interesting. So modules by itself are also referenced by atoms. Okay. I think it's slowly starting to make sense. This time the supervisor started a names registry, allowing us to create buckets without having to explicitly fetch the PID from the supervisor. You should also know how to make the registry crash again without looking up the PID. Give it a try. Yeah, I can do that. Process or GenServer.stop or call. I can do like GenServer.call queues manager YOLO crash. Sweet. That's cool. At this point, you might be wondering, should you also locally name bucket processes? Remember, buckets are started dynamically based on user input. Since local names must be atoms, we would have to dynamically create atoms, which is a bad idea since once an atom is defined, it is never erased nor garbage collected. This means that if we create atoms dynamically based on user input, we would eventually run out of memory, or to be more precise, the VM will crash because it imposes a hard limit of the number of atoms. This limitation is precisely why we created our own registry, or why one would use Elixir's built-in registry module. Oh, this is what we need. Oh, there's so much already done for us. All of these use cases already exist. So Lily, welcome back. How was your homework? This just makes me scared. Why does it make you scared? Homework sucks. We're getting closer and closer to a fully working system. The supervisor automatically starts the registry, but how can we automatically start the supervisor whenever a system starts? To answer this question, let's talk about applications. So we have been working inside an application this entire time. Every time we change a file, we run mix compile, we could see a generated KV app message in the compilation output. We can find generated .app file at build dev lib kv ebin kv.app. Okay, like if we run, let's do that. Mix compile. Open. Where does it build? Underscore build. I don't see it. Oh, here. Dev lib kv. Oh no, not in our case. Not in our case. Not in our case. It's Viewer Games. Ebin. Viewer Game app. Have a look at its contents. I'm scared. Wow. I did way too much. Yeah, I'm gonna go. Cannot listen to this. Good night, Lily. Thanks for stopping by. Goodbye. Wow. Interesting. The file contains Erlang terms, written using Erlang syntax. Even though we're not familiar with Erlang, it is easy to guess this file holds our application definition. It contains our application version, all the modules defined by it, as well as a list of applications we depend on, like Erlang's kernel, Elixir itself, and Logger. Yeah, we have a way more complicated app because we're using Phoenix. But by default, this will be the app. The Logger application ships as part of Elixir. We stated that our application needs it by defining it in the extra applications in mix.exe. True. Oh, that's what that is for. Interesting. In a nutshell, an application consists of all of the modules defined in the app file, including the app file itself. An application has generally only two directories: ebin for Elixir artifacts, such as .beam and app files, and priv with any other artifact or assets may need it in your application. Although Mix generates and maintains the .app file for us, we can customize its contents by adding new entries to the application function inside the mix.exe project file. We are going to do our first customization soon. Each application on our system can be started and stopped. The rules for starting and stopping an application are also defined in the .app file. When we invoke IEX as mix, Mix compiles our application and then starts it. Let's see this in practice. Start the console with IEX as mix and try start. Oh, IEX as mix. Application start. Viewer Games. Is that what our app is called? Yes. Already started. It already started. Mix start the application and all its dependencies, but this is also true for mix test and many other mix commands. You can change its behavior by giving it a no start flag to mix. Okay. Oh, IEX mix run. No start. Application start. Viewer games. Error, not started. Runtime tools. Oh, we need to start that first. Oh, yeah, okay. You need to start all of the other applications, I see. And then this thing depends on Hackney. And then that thing depends on Itna. And then that thing depends on Unicode. Unicode util compat. And then that thing, and then this thing, and then Hackney. And then that thing doesn't start because it also needs mim Errol. And then Hackney. And then it needs that. Okay, cool. I understand. And you can stop pieces of it. Interesting. Ensure all started. Oh, I think I've seen that somewhere. Where have I seen this? Application dot ensure all started viewer games. Okay, boom. All of that is now booted up. Runtime tools, Unicode this, all of this. Interesting. I see. I'm learning so much. Like, this is all kinds of docs that I've just skipped. There's so many useful docs. Whenever we invoke IEX as mix, mix automatically starts our application by calling application.start. We can customize what happens when our application starts. As a matter of fact, we can. Oh, but can we? And yes, we can. To do so, we define an application callback. The first step is to tell our application definition which module is going to implement the application callback. Let's do so by opening mix.exs and defining def application. The mod option specifies that the application specifies the application callback module, followed by the arguments to be passed to the application start. The application callback module can be any module that implements the application behavior. Interesting. To implement the application behavior, we have to use application and define a start function. Okay. I think that's what this thing is. Start, type in args, and then our mix.exs specifies nothing as the arguments. Please note that by doing this, we are breaking the boilerplate test case, which tested the hello function. You can simply remove the test case. Okay. Okay, so yes, see, this is important to note. So our application, viewer games application, like specifies this, and this is not used anywhere. But this can be useful when you want to debug, because you can actually just hook up into the system and see the whole supervisor tree from here, because this is the start of our app. And because literally from the start of our application, it is a supervisor tree all the way down, you can introspect any plays of your system at any point in time. Because if you have access to the supervisor, you have access to the children of the supervisor, and then you can find a specific one that you're looking for. Supervisor is easier than monitors. Not sure what you mean. like to introspect like I mean, yes. If I needed to by hand like monitor all of these and register them somewhere, then yes, that'll be a lot of work. And also listening to their events when they crash and like what to do. A lot of good work. But this is like interesting to know. It's like you registered this atom anyways, so that I can actually introspect and reference and ask supervisor, hey, give me this specific supervisor with this name, so that I can do some checks. Because I think the supervisor has some very interesting methods. Like, this is what I've seen in a video. Oh, wow. Didn't know that. Count children. Name. Start link, stop, terminate child, which children. Yeah, so I think what I saw live, like somebody live debugged and hooked into an existing running application and then just like find the children and then find the child that is like stuck in like working, and then you can just terminate the child of that supervisor while the application was running. Very interesting stuff. Cool. Yeah, so that makes sense. So I have the top level supervisor name that I can hook into and inspect. And I think there's even a like in Erlang there's even like some debugging tools that you can use that will like show you like all of this, the supervisor trees and stuff. Okay, where are we? When we use application, we may define a couple functions similar to what we used in the supervisor or GenServer. This time we only had to define start function. The application behavior also has a stop callback, but this is rarely used in practice. You can check the documentation for more info. Now that you've defined an application callback which starts our supervisor, we expect the KV registry process to be up and running as soon as we start IAXS mix. Let's give it a try. I see. So if I define here viewer games.queues.supervisor, it should automatically boot up when I do IEX. Oh. Syntax error, viewer games. Oh, comma. So now I can do viewer games alias viewer games dot queues dot manager dot create queue for queues manager. Just draw cats. A process is not alive. Interesting. Starts a worker by calling viewer games worker start link. Fine though, right? What does the supervisor need? Options. Oh yeah, I need to define that this one uses the name. This. Recompile. Fuck, it still doesn't work. Process is not alive. Process.alive question mark. Use supervisor. Argument error. Case process alive. Viewer games dot supervisor. Supervisor dot which children? Supervisor, there is a supervisor running and it's called okay. Use that supervisor. Does it need to be like the full name? I thought aliasing would work, but let's just try it. Found children. Process is not alive. Wait, but it says it's alive though. What am I doing wrong? So the supervisor is not up, which starts a manager by the manager name. Supervisor starting. Maybe the recompile doesn't work. Oh, so it is up. Viewer games dot queues dot supervisor. Then we do process alive question mark. What? As it's starting. Started this. Started with the options. What is the options? Viewer games use supervisor. It adds it here. You need to do process.where is. Process.where is. Yeah, so that exists, but like I have it defined by name, so shouldn't I be able to call it by name too? Like there is a running version that has a manager like process now defined. I have now a manager that is running here. Which should also have the name manager. So like I should now have one supervisor with the name of supervisor, and I should have one manager with the name of manager. That's what I'm confused about. What about process where is viewer games dot queues dot manager? That also exists. But why can I not reference them? If I do viewer games dot queues dot manager dot create queue, and then viewer games dot queues dot manager, and then just draw cats. Oh, so I guess it was just affected. It was not recompiled. Cool. So now we have a queue for viewer games dot queues dot manager dot get queue by viewer games dot queues dot manager, and then just draw cats. And now we have a queue, and then we do queue. Let's alias viewer games dot queues dot queue dot join queue Bob Ross. Cool. And now if we do queues dot queue dot leave queue for like players queue, we get Bob Ross back, and then if that queue crashes, it loses all of its state, which is fine, because that's just how we tie this into. But maybe I should also write to disk or to Redis in order to save it. This is so cool though. I'm really excited about this. So now let's try this using aliases actually. So manager, let's get queue for queues manager, just draw cats, and about somebody else's error. Good. I don't know why it wasn't working before, but maybe that was just because I was using recompile rather than actually restarting the application. That's okay though. Cool. That is sick. I just have so much more understanding of how this stuff's supposed to work now. Makes so much more sense. These docs are actually really good. And before I just skimmed through it, but if you really read through it, there's a lot of knowledge. Like sometimes you just have to read. That's hard. Reading is hard. All I want though is that they also make a dark mode. Because it's now almost 1 a.m. I need to work tomorrow, but like this is very bright. Alright, let's slowly wrap it up. Because we have a lot done already. I think the next stream, so we do Tech Wednesdays every Wednesday. What a surprise. I think the next stream, we would refactor the manager to just be a registry. Because that's very easy. Like we don't need to have this. Would not have this all under the hood. We can just do this by creating a registry. Let's see where we are though. Let's see what's left. So this. Rarely used in practice. Now that we have defined an application callback which starts our supervisor, we expect the KV registry process to be up and running as soon as we start IEX/-s mix. Let's give it a try. That's what we did. Recap what's happening. Whenever you invoke IEX mix, it automatically starts your application by doing application start, which invokes the application callback. The application callback's job is to start a supervisor tree. Right now, our supervisor has a single child named KV Registry started with the name KV Registry. Our supervisor could have other children, and some of these children could be their own supervisors with their own children, leading to so-called supervision trees. Mix makes a distinction between projects and applications. Based on the contents of our mix file, we could say that we have a mix project that defines the KV application, as we will see in later chapters. There are projects that don't define any application. When we say project, we should think about Mix. Mix is a tool that manages your project. It knows how to compile your project, test your project, and more. It also knows how to compile and start the application relevant to your project. When we talk about applications, we talk about OTP. Open Telecom Platform. Oh, didn't know that. Applications are the entities that are started and stopped as a whole by the runtime. You can learn about the applications and how they relate to booting and shutting down of your system as a whole in the docs for the application module. Okay, that's something I need to look into. Although this chapter was the first time we've implemented a supervisor, it was not the first time we used one. In previous chapter, when we used start supervised to start the registry during our test, XUnit started the registry under a supervisor managed by the XUnit framework itself. By defining our own supervisor, we provide more structure on how we initialize, shut down, and supervise processes in our application, aligning our production code and test with best practices. But we're not done yet. So far, we are supervising the registry, but our application is also starting buckets. Since buckets are started dynamically, they have to be supervised by a special type of supervisor called the dynamic supervisor, which we will explore next. Holy shit. There is more. Oh my god. It's like they thought of everything. They've already solved all of the problems that you would want to do with your process. Cool. So next Wednesday, we'll be diving deeper into dynamic supervisors and also refactoring our manager to use a registry rather than rolling our own. That's cool. This is super sick. Because it's like the getting started is actually really nicely structured because it first lets you do it without the abstraction and just like building it raw. And then they tell you like, well, you didn't really think about these problems yet, but here are some of the problems with your current implementation that we've solved for you in this abstraction, so you don't have to worry about it. So that's great. That's really cool. Sweet. All right. Thanks everyone. Let's commit this. Maybe queues and then queues manager. Maybe that makes more. Ads. Oh, let's lint or format. All right, let's add supervisor of our manager to the applications supervisor. So in theory, instead of having that supervisor, we could have also just registered this all the way at the application. So like what we could do here is rather than queue supervisor, we could have just done queues manager. But like, I think this is a good practice. Like you have a supervisor for your domain, and then your domain starts a bunch of other processes in its own supervisor. So in this case, we're only starting the manager, but it might create like more for this specific queues domain. So I think that makes sense. Let's publish. And then we also have the other one. It's this one. Oh, we already pushed that one. Cool. Sweet. Yeah. Okay. Thanks everyone. Thanks everybody for watching. So next Tech Wednesday, we'll be diving a little deeper into the dynamic supervisors and the registry. And so I hope you guys enjoyed it. Nonetheless, I hope you learned something. If you are new or watching this on YouTube, feel free to subscribe to my coding YouTube channel. If you're watching this on Twitch, my coding YouTube channel is over there. It's called just Code Cats, but I think in theory it's all tech stuff that I do. So it's like my Tech Wednesdays channel pretty much. For now it's just like VODs that I upload straight from Twitch, but I think in the future it would be cool to just do like small tutorials or small projects or small like videos of progress that I've made with like some of the side projects that I have. But that is still yet to come. For now, it's just a dump of like the programming streams so that I have some sort of archive for myself, and also people seem to enjoy it, to just have something on while they're working, or when they're interested in Elixir, they can just go back to these videos. Since my VODs will be deleted after 30 days, they can just go back and see like, oh yeah, shit, I remember this from the stream. What was it again? So yeah, if you like the stream, give it a follow. And if you enjoyed Tech Wednesdays, feel free to tune in next Wednesday. I stream Mondays and Wednesdays. Mondays is my more like gaming stream, and then on Wednesday I do my coding/tech streams, which could be anything from just soldering shit to like electrical engineering to, in this case, Elixir and learning GenServers. So if you enjoy that, feel free to follow. Anyways, have a good night, everybody, and see you guys later.